Hi Geometry. This is Unit 2, Lesson 7, page 234 of our workbooks, and these are notes about the angle side angle triangle congruence theorem. So let's read number 1. Two triangles have two pairs of corresponding angles congruent, and corresponding sides between those angles are congruent. Sketch two triangles that fit this description. So let's begin with what the description says. It says two pairs of corresponding angles and corresponding sides between those angles. The word between is super important. So let's start drawing two angles and the side in between. So right here, I have this blue side. Don't worry about the tick mark at the moment, but I have this blue side and I have a purple angle drawn on it and a red angle drawn on it. So on your paper, if you would draw a similar side and then mark off an angle, some angle measure, and then mark off a second angle measure. So it's talking about this being a triangle. So when I go to sketch my triangle, I can sketch this side over here. I could sketch this side lots of places. However, if this is my angle, then my side better enclose my angle. So let me draw a side here that encloses that purple angle that I drew. So then that would be the sketch of one of my sides. And on this side as well, I could draw my side anywhere I wanted, but if it's going to enclose this red angle, then it has to run right up against it. And it looks like this is a picture of this particular triangle. If I'm given this fixed blue side and I'm given the two angles on either side of it, because this blue side is my side between, then this is the triangle I have to get. No matter what I do, I have to draw that particular triangle that you see on my paper. So let's try to do a second one that has the same blue side, the same purple angle, and the same red angle, and see if we get the same triangle. So again, take a moment, and whatever your side look like, sketch that side, put a tick mark to show that your two sides are exactly the same length. However you made this red angle on your paper, make an angle about the same size. And then however big you made this purple arc, make that same angle about the same size here. So again, that's what's fixed. I have two angles and the side between them. So let's see what kind of triangle I can draw. Again, this side, when I get ready to draw it, I could really draw it anywhere. But if it's got to enclose my red angle, that means it has to go right next to my red angle. And here, same thing, if it has to enclose my purple angle, then my side would be about right here. And you'll notice when I do that, my two triangles are the same size. That's because angle, side, angle. So I have my purple angle, I have my included blue side, and my red angle. The angle side angle is a congruence theorem. If I happen to know specifically two angles and the included side, then my two triangles have to be congruent. So number 2, it says label the triangles W, X, and Y, and D, E, F, so that W is congruent to D, X is congruent to E, and we know how that works. My corresponding vertices have to be equal. So you can put them anywhere you want. I'll call my purple angle W. So then in my other triangle, that makes it D. I'll call my red vertex X. So then in this one, it makes it X. And then finally, my leftover angle will be Y down here. And my leftover angle will be F. So I know my triangle WXY is congruent to my triangle DEF. And it says that side WX is congruent to DE. And so WX, oh, sorry. I think when I was talking, you guys, I was supposed to label this one E. Can you go back and fix it? So right here, it says that X is congruent to angle E. So if this is X, then this would have to be E. You probably already caught that. So then let's take a look at 3. It says use a sequence of rigid motions to take WXY onto DEF. For each step, explain how you know that one or more of the vertices line up. So first of all, using a sequence of rigid motions, it looks like for me it would be just a translation and then it would line up. It looks like I just have to draw this in my patty paper and then maybe move W to D. So then when it says for each step, explain how you know, that is from my sentence frame worksheet. So we've done that several times in our practice. So we're not going to do that here, but it just means that I know when I do a translation that moves W to D, that X has to line up on E because they're the same distance from W from D. I know that Y has to line up on F because the distance Y is from X is the same distance that F is from E, and those sentence frames that we had been working with. So let's move on and take a look at 7.3 we'll be doing in class. It's just a parallel line review. So let's flip to 7.4. So it says, what do we know for sure about parallelograms? So quadrilateral ABC is a parallelogram. So take a moment and sketch a similar ABCD on your paper. And by definition, we know that parallelograms have opposite sides that are parallel. Oh, sorry, it went very blurry. Was that because my hand was there? Take my hand out of it. Sorry about that. So we know that opposite sides are parallel. So in this case, AB is parallel to CD. So let's mark that. So AB and CD, I'm going to mark with a single arrow. And then BC is parallel to AD. So let's mark that. I'm going to mark it with a double arrow. And that's what we know for a fact about a parallelogram, because that's the definition of a parallelogram. But we can prove lots of other things about them. So let's take a look at something right here. It says to draw an auxiliary line. Well, what does that mean? An auxiliary line, and I'll do that in green, is just a line I draw on my figure that connects any 2 points that I want it to. So in our picture, why don't we could do AC if we wanted to, or we could do DB. Let's go ahead and do AC. So just connect A to C with this green line. I've now created 2 triangles. That's why it says, show how ABCD can be decomposed into 2 triangles. So I've got my 2 triangles, the one on the top right and the one on the bottom left. So what do we know about these 2 triangles? So let's take a moment and begin by looking at the first part of 2. It says, prove the 2 triangles you created are congruent. So let's stop there. To prove the 2 triangles are congruent, I need to either show side, 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 angle, side, angle, side, angle. And then there's 2 others we have yet to talk about. One of them is angle, angle, side, and the other one is HL for hypotenuse leg. But I need to see which one of these I have. So let's stop and look again at what I'm given. So we learned about alternate interior angles in Unit 1. And so let's think about this as a Z. If I take the top purple line and my bottom purple line, and I draw this green line, that is my transversal, so this is the top and the bottom, then I know that this angle and this angle are alternate interior angles. The green line is my transversal, and so this little angle and this little angle would be congruent because alternate interior angles are congruent. So let's mark those angles. I'm going to mark them in purple. So I have another set of alternate interior angles in this picture. If now I take my sides, my AD and my BC, and I draw that same transversal, so now I'm looking at my picture this way, sideward Z, I can see my other pair of alternate interior angles. This angle and this angle would have to be congruent because they're alternate interior. So let's put them on my picture. So I have this angle and this angle. So those angles, the red angle and purple angle, are marked because alternate interior angles are congruent. Okay, great. And then there's something else we haven't marked here. This is a property we've been working on, but these two triangles share a side. They have a side in common. If I could put my fingers on the paper and press really hard and pull them apart, they both have this green side in them. So the green side is congruent in both triangles by the reflexive property. And then the green side is congruent by the reflexive property. So these are things that I know as I study this picture. And so when I look at my reasons why, if I look at the top triangle, I can see my angle side angle in the top triangle is congruent to the angle side angle in my bottom triangle. So therefore, my two triangles are congruent by angle side angle. I can visually see my angle on my side. My angle, flip upside down, angle, side, and angle. So then it says explain why one pair of opposite sides of a parallelogram must be congruent. So first of all, I know that my triangle, I'm going to call it ABC on top, is congruent to my triangle on the bottom. So now corresponding vertices. A, the purple one on top, goes to C, the purple one on the bottom. B goes to D. And then finally, C on top, the double red, goes to A for my triangle on the bottom left. And so this would be A. This would be one where they twist around the midpoint. So if I had my patty paper, I would see that I have a twist. So then my A goes to C, C goes to A, corresponding vertices. So I know this by angle, side angle, triangle congruence theorem. So now I know all 6 parts. This is where I know all 6 parts, not just the 3, angle, side angle. I now know all 6 parts by CP/CTC. So I could say AB is congruent to, careful, CD, corresponding vertices, by CP/CTC. It says explain why one pair of opposite sides must be congruent. So the top must be congruent to the bottom. And AD on the side here would be congruent to BC. So I know that AD is congruent to, I have to write that how, CB, yeah, get my corresponding vertices in the right spot, also by CP/CTC, because all other parts of my triangle, all other 6 parts are now congruent. So I'm going to mark these with a double tick marks to show that those sides are congruent. And finally, I could also say that D and B are congruent. I can say that angle D is congruent to angle B. And if I wanted to say that, my reason is because they are corresponding parts of congruent triangles. Therefore, they're congruent. That's what CP/CTC stands for. I don't have to write it every time. I can just write CP/CTC. So let's take a look at the summary on this page right here. So clearly, sometimes it's easy for me to see my angle, my included side, and my angle. Sometimes it's really easy to see the angle, side angle in the picture. Other times, such as when I have a parallelogram, I have to mark things that I know because I'm smart, because I've been studying my geometry. So if my opposite sides are parallel, my top and bottom, that could give me A and C being congruent. If my sides are parallel, then I have my other part of angle A, my other part of angle C congruent. And then the other thing I know is that I have a shared side by the reflexive property. Again, angle, side, angle is why those two triangles would be congruent to each other. So continuing on to practice on page 238, I want to talk about the things that you mark because you know them. I want to talk about things that you mark because you're smart. So in this first diagram, number 1, I want you to take a look at this picture. So right now I can see angle A is congruent to angle C, and I can see that side CE is congruent to AE. And that's all I know. Nothing else is marked. I know other things look true, but I need to know what I know for a fact. So I want to remind you of something else we learned in the first unit. We learned about vertical angles. Vertical angles are congruent. And in this picture, I have a set of vertical angles. When my two lines cross each other, I have a set of vertical angles that would be congruent. Let's mark them with two arcs. And in this way, now that I've marked what I know vertical angles, I can clearly see that this is an angle, side, angle, angle, side, angle. So they're congruent by the angle, side, angle congruence theorem because I marked my vertical angles. Again, looking at this picture, this is slightly different. In Han's problem, I don't know it's a parallelogram. I only know the top is parallel to the bottom. I don't know anything about my sides. So in this picture, if I wanted to mark alternate interior angles, you have to be really careful. My parallel sides are the tops and bottom, and this is my transversal. So I only have one pair of alternate interior angles in this problem I can mark. It would be in between the parallel lines and the transversal. I cannot mark this angle like I did in the problem previously because I don't know that AD and CB are parallel to each other yet. I don't have that information. So in this problem, I can clearly see I have an angle and an angle congruent, but right now I don't have anything else. Again, this is where I have to think about what I know. And generally what you know are vertical angles, alternate interior angles, and my reflexive property. So I would have to mark this. So now be careful here. I have an angle, and a side. This is not angle, side, angle. I don't have the two angles on either end of the side. So this would be an example of the angle, side, triangle congruence theorem. You could also say side, angle. That's fine. There's nothing wrong with that. Usually we say angle, side, but it's the same thing to me. But notice where the S is for the side. It's not in between the two angles because in this picture, my congruent side is not in between my two angles. So that's why I can't write the S in between my two angles in this statement. And finally, let's take a look at number 3. It says segment GE is an angle bisector of both HEF. HEF is the large angle on top, and FGH. FGH is the entire angle at the bottom. So I want to go back and remember what an angle bisector did. It split something in half. So if GE is an angle bisector, that means that it's splitting this angle on top in half. So I know that either side is equal to the other one. And if it splits the larger angle on the bottom in half, then I know that this half has to be congruent to this half. So now I want you to think about what else you know in this picture, because you're smart. What else do you know? And then what reason would these two triangles be congruent based on that? So finish up 1, 2, and 3, making sure you've marked them correctly, and bring those to our next class with you. Thank you very much.